So we have a rectangle class here, rectangle with side A, side B, and an area variables. These are both public integers. And then a compute area method, where actually the area, this area variable here, that I put here, gets set to side A times side B. So basically a rectangle area. Now, I have a test rectangle class that is actually all it does is has a main method where I create one rectangle, rectangle 1, R1, and I set the side to 8, the side B I'll set to 10, compute area, which should leave the area as 80, and then I have a system out print line R1.area, which we compile and we will test to see what comes out of this. Let's run it. And as expected, I get the number 80. Okay? Now, here's something. So if the idea of coding a class is that once I have my rectangle class, I can give it to you, the viewer of this video, and you can use it for a test rectangle or for a program that draws rectangles or for something else. Okay? Now, an ill-intentioned person might actually say this. Look what happens if I do this. R1 dot area equals negative 90. I'll compile this. This compiles. I'll run it. And the area now is minus 90, when actually the sides were 8 and 10, and the area should have been 80, right? But there's a problem here. You can go ahead and change whatever you want in the rectangle, and that's not the idea. The idea is that if I give you a rectangle class, it will behave as you would expect a rectangle to behave. So how can I ensure that you compute the area but you don't manipulate it further? Well, one way of doing this is we go to the rectangle is change this public modifier here into private. If I say private in area, the only methods that can change the value in area are the methods in the rectangle class, meaning anything between these two sets of curly braces there. Okay? Therefore, if you want to change the area, if this is private, your only way to do it is computing the area. So if I go to test rectangle and I try to compile this, I'm going to get an error. It's going to say area has a private access in rectangle. So I cannot call r1.area. So this line is now good. And now the other thing is I cannot even call it here. So perhaps what I want to do is get a method, a public method, so because the method is public, you can access the method. Public int get area, which will actually return the area, okay, the variable area. What happens with this, what I've just created, get area method is a way to read what is in the variable area. So R1, I will call get area, and that should actually return or evaluate to an int to actually the value of the variable area. So let's compile this and run it, and I should get my 80 back. Here's 80. And the good thing about this is that because you set the sides to something, the rest of the rectangle behaves like you expect. There's no surprises here. And I have used a method called get and then the name of the variable to get the value of the variable. I coded it here. This is called a getter or an accessor. So this is a getter or accessor. Okay? Now, we still have a problem. Somebody might just want to set the sides to -8 by mistake, right? And we compile it and run it, and the area becomes negative. This is not right, right? This is just not right. So what we can do with this is actually side A and side B, make them private, and you cannot access them directly. You cannot just modify them like that. You'll have to modify it through a method. So what I'm going to do is I'm going to create this private here. I'm going to make this private. Private side A, private side B. And if I try to compile this, I'll get a bunch of errors telling me that side B has private access, side A has private access. So the question becomes, well, how do I set the sides of this rectangle? Well, we can create a couple of methods for this. We can create a public void set side A. This will receive an integer, and that integer that it receives will actually be put to side A, right? So you can say side A equals A. And public void, the same thing for side B. And B. The names of these variables here, if you looked at the video on functions, these names A and B, they don't matter. They can be the same. They can be called fluffy and muffy, whatever you want. So then we set this side B equals B. Remember, I can do this because although the variables are private, private means that anything within the rectangle class can actually change those variables to whatever they want. Okay? So now I have two methods to set this. So I'm going to use them here. Instead of saying that side A equals -8, I will say set side A to 8, and this is set side B to 10. Now this program compiles, and I will get the expected 80. But I still have the problem that if I put it in -8 here and compile and run, I'll still have the -80. But here's the beautiful thing about this. Because you're calling a method, I can just go to this method and code whatever I want in here. So what I can do here is to say if A is less than 0, meaning if A is negative, then A equals -A. Basically, you switch the sign, right? And the same thing happens for B. If B is less than 0, then B equals -B. Okay? So I'll save it, compile this. Whoops, compile this one. And if I run it, look what happens. I get 80. Because this -8 gets converted into +8, right? So there's no way of me screwing up with negative numbers here or anything like that. My class is what's called encapsulated, okay? The rectangle class is encapsulated, meaning it just works. It works and you don't need to know how it does what it does. You cannot access its internal variables. You just call methods on it that are very intuitive and it just works. By the way, these methods that start with the name set and then the name of the variable are also called setters or mutators. Okay? The same thing for the set side B.